All right, day 2 of our EOY exam review. So we're going to start off with some triangles. Well, specifically in this case, which condition would prove that triangle DEF is similar to triangle JKL? So when we're talking about similarity, there's really only 3 different ways that we can prove similarity with triangles. There's side, side, side similarity. There's side, angle, side similarity. And then there's angle, angle similarity. So first thing, let's just take a look at what we have here. Well, we have a couple of angles, D and J, and we can see that it's first letter. So those are definitely corresponding angles, D and J. And then we have side DE and side JK. DE first 2 letters, JK first 2 letters. So we know that these 2 sides are the congruent ones. Okay, so what do we have? We have a side and an angle. Well, if we've got a side and an angle, another side would be the thing that we're really going to need. In this particular case, we would need to know something about side, angle, side DF, or side, angle, side JL. So we're looking for DF and JL. So if we're looking at our options here, DF and JL, well, that really is only going to be either B or D, because those are the only ones talking about DF and JL. So we know it can't be those 2. So now we can see that we've got some kind of a ratio here. So this is going to be our scale factor. How are things scaling down? So what we're going to do is figure out our scale factor here. So if we're going to compare DE and JK, right now we can see that DE, okay, and JK, okay, well, DE we can see is 14, JK is 7. So it's a ratio of 14 to 7, but we can see that that simplifies as a 2-to-1 ratio because both of those numbers are divisible by 7. Okay, so we're looking for the one that has a 2-to-1 ratio of DF and JL, so that's why our answer is going to be B. Okay, so that we can see that we have similarity by side, angle, side, similarity. All right, let's take a look at our next one. So what is the value of x? So with this kind of a triangle here, we've got this embedded triangle, we've got 2 sides parallel to each other. So we can actually use a theorem here that allows us to say that since these are parallel to each other, what we can do is we can set up a couple of different ratios between this piece here, this 2x minus 8 that's between here and here, and the 5 there and there. We can compare that to the other side, this x minus 3, and the 3 between here and here. So we can set up a couple of different ratios. So let's set up the 2x minus 8 in relation to this segment here. So this 2x minus 8 is going to be set up as a ratio with the 5, and let's make it equal because we're looking at different triangles here that are a dilation of the original one of this x minus 3 over 3. So we can see that we've got a set of ratios here. Now we can go ahead and cross multiply and divide these 2. So let's cross multiply these. So we've got 3 times 2x minus 8 is going to be equal to 5 times x minus 3. So let's get rid of our parentheses with a little bit of distribution. 3 times 2x is a 6x. 3 times a negative 8 is a negative 24. Okay, 5 times x is a 5x. 5 times a negative 3 is a negative 15. All right, so now we just got to solve this for x here because this is our main question. What's our value of x? So much like we've seen before, we're going to get all of our variables onto one side, all of our constants moved over to the other. So let's subtract 5x from both sides. And let's add 24 to both sides. Okay, so the 6x minus the 5x, that's just a single x. The 24's cancel. So we're just left with an x over here on the left-hand side. the 5x and the minus 5x cancel, but now we have a negative 15 plus a 24. Okay, so a negative 15 plus a 24, 24, let's try that again. So we're just looking at a 9. So x is equal to 9.